An acid-base reaction generally forms an ionic compound called a salt and water. The salt usually remains in solution, so it is our aqueous product. Acid-base reactions also occur via double displacement. And remember that has the general form AX plus BY to give AY plus BX. So let's look at the reaction of nitric acid and potassium hydroxide. Since hydrogen is the plus and hydroxide is the minus, those two will hook up to form water. And nitrate is minus, potassium is plus, and those will hook up and form our ionic compound or the salt. So our products are potassium nitrate and water. This acid-base reaction is balanced already. We can see that we have the same number of atoms of each kind on both sides. Just like in our precipitation reactions, we can write an ionic equation once we have a balanced equation for the reaction. Before we write the ionic equation, let's identify the strength of our acid and our base. We know that nitric acid is a strong acid, and potassium hydroxide is a strong base. Remember that strong acids and bases will ionize or dissociate 100% of the time in aqueous solution. So our ionic equation will be H plus and NO3 minus, coming from the 100% ionization of our strong acid, plus K plus and OH minus, coming from the 100% dissociation of our strong base. We know that soluble ionic compounds in aqueous solution will also dissociate, and so we have K plus and nitrate from the potassium nitrate. And liquids don't dissociate, so we'll leave our water as is. We get our net ionic equation by canceling out spectator ions or species that occur on both sides. So we have nitrate on both sides and we have a potassium on both sides. And our net ionic equation is the formation of water. We will always get H plus OH minus to form H2O from the reaction of a strong acid with a strong base. Okay, let's look at the reaction of phosphoric acid with sodium hydroxide. So phosphoric acid is a weak acid, and sodium hydroxide is a strong base. Hydrogen is +1, phosphate is -3, sodium is +1, and hydroxide is -1. So we know that our hydrogen is going to switch and take the hydroxide, and phosphate is going to switch and take the sodium. Remember that we write products based on the charges and not on the number of atoms that we have. We can deal with that when balancing the equation once we have our equation. So sodium is +1, and the phosphate ion is -3, which means that we need to have 3 sodium for every phosphate. So we end up with sodium phosphate for our ionic salt. And we know that hydrogen and hydroxide form water. This time we don't have a balanced equation, so we need to balance. Let's start with sodium. I see that I have 3 on the right side, but I don't have 3 on the left. In fact, I only have 1. So let's put a 3 here. And so now I've got 3 sodium on both sides. But that gives me 3 oxygen and a total of 6 hydrogen if you add all the hydrogen on the left. And so we need to put a 3 in front of the H2O. so we balance out those hydrogen and oxygen atoms. Now we're ready to write our ionic equation. If we look at phosphoric acid, we've identified it as a weak acid, and so that will not ionize 100% in aqueous solutions. So we can't break that up into its ions. We have to leave that as H3PO4. However, sodium hydroxide is a strong base, and so we know that it will dissociate 100% in aqueous solution, which gives us 3Na plus aqueous, don't forget about that coefficient, plus 3 hydroxide ions. And on the products, sodium phosphate, that's our salt, our ionic compound, and so that's going to dissociate, give us 3 Na plus and 1 phosphate ion. And our water doesn't ionize, so we'll leave that as is. We can cancel out any spectator ions to get our net ionic equation. So in this case, we've got 3 Na plus on the left and 3 Na plus on the right. And there isn't anything else that we can cancel out. So our net ionic equation is phosphoric acid plus 3 hydroxide ions to produce a phosphate ion and 3 waters. Notice that this is different than the previous example. When we have a weak acid and a strong base, our net ionic equation is not the formation of water.